Well, welcome to this online revision session for AQA M2, in which we'll be looking at the January 2011 question 6 on circular motion in a vertical plane. So in this question we have a light and extensible string of length A fixed at O with a small bead of mass m attached to it. And the bead is moving around this vertical circle, and initially at B its speed is 5v, and we're told in part A that when the the bead, which we're treating as a particle, gets to the top, I'll call the top T, then the speed at this point is 3v. And we've got to find V in terms of A and G. So the method that we use for this is to analyse energies, since we have gravitational potential energy changing as we move from B to T, the kinetic energy changing as we move from B to T, and since the only external force is the tension in the string, but that is perpendicular to the motion at all times as it moves around the circle, then does no work, we know that the energies are conserved. So let's look at an analysis of those energies. So if we start with B, initially we can take the GPE, the gravitational potential energy, to be 0 at that level. And the kinetic energy we know is a half the mass times the velocity squared, or the speed squared I should say, which will give you a half m, and in this case the speed is 5v, so that needs to be squared. Similarly at T, well, we know when we get to T that is 2a, the diameter of the circle, above B, so the GPE will become mg times h, so in this case it's mg times 2a, and similarly its kinetic energy will be equal to a half m, and this time its speed is 3v squared. And as we said, energy is conserved, so we can say that by conservation of energy, it's useful to write these little notes in, we can then say that the total energy at B, which is a half, well it's going to be a half times 25, so we can call that 25 over 2 mv squared, must equal the total energy at T, which is going to be 2 mga plus, and then this will be 9 over 2 mv squared. The mass then of the particle is actually not relevant, it will cancel out through this expression. So we've got 25 over 2v squared, and we can take the 9 over 2v squared across to give 16 over 2v squared, which will just give you 8v squared. So 8v squared must equal 2ga. Now we can divide through by 8 and square root to give us that v must equal 2 divided by 8 is a quarter, 1 over 4, square root of 1 over 4 is a half, and then we get the square root of ga. 4 marks for that question. So a method mark for analysing the energies correctly, and an additional mark for accuracy if you've got all the energies that you should have in place. Retaining the 8v squared being equal to 2ga, part mark way through there, and then square rooting the answer and obtaining the correct expression for v gives you your 4th mark. Now, part B of the question, we're being asked to find the ratio between the greatest and least tensions in the string. Now those will occur at the bottom of the circle when the speed is at its greatest and the weight of the particle is acting in the opposite direction to the tension in the string. Remember, there is a tension in this string here, T. Whereas at the top of the circle, the weight is acting in the same direction as the tension, and so that will reduce the tension that's required in the string to maintain the circular motion. So if we consider what is happening at B, if we analyse the vertical forces there acting towards the centre, we've got T minus mg must equal mv squared over r. So in this case that is m 5v squared over a, because a is the radius of the circle. So that will then tell us that T must be equal to, well, we know from the previous part of the question that V was equal to a half root GA, so we can substitute that in, and so if we put that in for the 5V, that is going to give us GA rooted when squared just gives you GA, so the A's will cancel, so you'll get the mg out, and then we've got the half squared, which is a quarter, and the 5 squared, which is 25, so that gives us 25 over 4 mg plus another mg from that weight being brought across to the other side, and so that simplifies down to 29 over 4 mg. So that's the tension when we're at B, so I'll call that TB to distinguish it from TT, which is the tension at the top. So when we do the one at the top, again we've got the tension acting towards the centre, TT, but this time the weight is also acting towards the centre, and that must equal the tension that's required in the string, which this time is going to be m times 3v squared over a. So once again we can now substitute in the half root GA, which again the A's will cancel, you'll get an mg, and this time we'll get 9 over 4 mg, and we've now got to subtract mg, that's the weight, and so that will give us 5 over 4 mg. Finally, we need the ratio of these tensions, So we need the ratio of the greatest to the least. So we need the ratio of TB to TT, and that will equal, well, we can see we've got 29 over 4 mg, 5 over 4 mg, so the 4, the m and the g are all going to cancel, so we'll end up with a ratio of 29 to 5. Okay, 5 marks for this. We're obtaining an appropriate expression here for the tension at B. We get a method mark and an answer mark for accuracy there. Similarly for the second one, for TT, we'll get a method mark here and an answer mark. And then finally, obtaining the correct ratio will give us our 5th mark. Well, hopefully you found that solution helpful. For more help with your maths revision, please go to the Further Maths Support Programme website.